The next topic we'll discuss and build upon is the concept of ratios. Ratios are a comparison of two or more quantities. We most often see them in situations like baking. If you have class in person this term, if you're lucky enough, I might make you cookies because that's a great example of using ratios. Because you want, what this is a set of relationships. If I have 2 cups of sugar, I need 3 cups of oatmeal. If I want to change the recipe, if I want to make 2 batches at once, I have to double those ingredients. So 4 cups of sugar and 6 cups of oatmeal. I can't just add an extra cup of sugar and an extra cup of oatmeal. That would throw off the ratio of the two and the recipe wouldn't turn out right. We can also use this, as we can see, talking about shirts and sweaters. Maybe we might use this for business planning purposes. If you're trying to plan out space in your store, maybe you want to look at what kind of sales you had, and so what kind of space you'll need, how many racks of shirts versus how many racks of sweaters you might want to have out on the floor display. So there's a lot of different purposes. We're going to also, we'll build off of the concept of ratios to get into proportions and proration and unit prices, things like this. So we'll get to all that shortly, but between this week and next week. Let's just look at a simple ratio to start. So we have an example. I think with numbers it'll be easiest to show it. Suppose a store sells 2,000 shirts and 1,500 or 1,500 sweaters in May. The ratio of shirts to sweaters is, and so I'm going to show you a few different ways you can express this ratio. So this is, in words, shirts, sweaters. That's how you would show the ratio. Quick note, please make sure to keep an eye on what order they ask for the information. Some questions in the practice are sneaky and they'll give you the information shirts to sweaters, but then they'll ask for it as the ratio of sweaters to shirts. So sweaters to shirts. So just take note of the order because it just changes the order of the numbers. Shouldn't change the relationship of them, but it might change what the answer looks like slightly. So shirts to sweaters. So we said there's 2,000 shirts, and they sold 2,000 shirts and 1,500 sweaters. So we can just write that down, 2,000 : 1,500. So that's our standard, that's a standard ratio format. But we can write it in other arrangements that are also useful. We could put it as 2,000 divided by 1,500. That's in a common fraction format, common fraction. And that's another way to express the relationship. If you're just looking at just a ratio with 2 terms, or you can take 2 terms from a ratio. My cookie recipe I mentioned has more than 2 ingredients, but I could take just 2 of the ingredients out and say, the amount of oatmeal I need compared to the amount of sugar I need, and I could set it up as a fraction type of format. We'll talk about reducing that fraction in just a minute, but let's look at 2 other formats. So what happens if you actually divide them? So if you divide, 2,000 divided by 1,500 gets you 1.33, well 1.33 repeating really, but if we round it, that's going to be a decimal, that's going to be our decimal equivalent. So you could express it in a decimal type of format. And what is that saying? Well, it's a little weird, but sometimes could be useful to think of you sell 1.33 shirts per sweater sold. You know, so you sell 1.33 shirts per sweater sold. And that could be useful information to think about it that way, especially as we'll discuss, depending on the numbers. Sometimes what we like to usually do is reduce or simplify these numbers, but keeping the same relationship, and we'll talk about that in a second. But sometimes the numbers are ugly and you can't reduce them nicely. So just straight up dividing is something you can do there. Or, well, we've done fraction and decimal. What else have we done in the course? Percent. So if we multiply that, we could say that's 133 and a third percent. So a percent equivalent and again, you sell 133 and a third percent the number of shirts as you sell the number of sweaters. So these are all different formats you could see a ratio in. Normally we'll see them in the standard ratio form, and we'll definitely use the common fraction form quite a bit. Now what we often do, I'm just going to do this, just showing some examples there, but in fact I'll separate it like that too. Common fraction form, what have we done with common fractions before? We have reduced them or simplified. Let's do that here. Let's reduce to lowest terms. So we're going to find an equivalent fraction that's the most simplified version of this possible. And I'll go into greater detail in a moment with my next video, but let's just do a quick one here. 2,000, so 2,000 over 1,500. When you're trying to generate equivalent fractions, fractions that ultimately have the same overall value, you can multiply or divide the numerator and denominator by any factor, as long as it's the same number. Like if I doubled both of those, 4,000 over 3,000, that would have the same relationship. It would, if you divided, you would get the same decimal number. So it'd be, you might have changed what the original numbers are, but you haven't changed the relationship between those two. You still know that you sell, you still have an idea of how many shirts you sell for a certain number of sweaters. Here, we're going to look and see what we can simplify the most. And in this case, well, those are both, you can easily divide some powers of 10 out of that, right? 2,000 over 1,500, you could divide both of those by 100 to start. So let's do that. Divide the top and bottom by 100, and now we have 20 over 15, which is a little bit easier to work with. Question is, can we simplify this any further? 15 is 5 times 3. Well, and 20, that's definitely divisible by 5. Let's divide them both by 5. And we get 4 over 3. And that is the most simplified version we can make. The reduced to lowest terms, I'll put down whole numbers. So when we reduce to lowest terms, we're specifically wanting it all expressed in whole numbers. So 4 over 3, that is the simplest you can do. If you divide any further, 4 divided by 3, you get 1.33. You're getting a decimal number. So really, this would mean you sell, we sell 4 shirts for every 3 sweaters. So that might be useful information if you're thinking about a clothing store and you are trying to plan out how to arrange your store, or maybe you have a new satellite store, like it's a franchise, and you're thinking, well, this tends to be how we do in the month of May, so let's plan to have 4 racks of shirts and 3 racks of sweaters, or something like that. I realize sweaters often take up a little more space than shirts, so, you know, but that's the idea. You may want to have more shirts available in the store because you know you're likely to sell more. Okay, so from here, we're going to look at a few examples initially here of simplifying ratios, and then we're going to start working with ratios and using them to solve some problems. I made a video. So normally I would do a lesson right now going further into techniques to most easily to reduce ratios to lowest terms. But this term at least, we ended up having some questions come up in unit number 1 that involved that needed some of that information. So I ended up making a different video early on. I am going to include that unit 1 video in the playlist after this video. So if you've already watched it, great. You can rewatch if you want a refresher, or you can just skip past it to us doing more problems, looking at some other fancier ratios and what we can do with them. Otherwise, it's nice to look through it. It's in that I am showing a bunch of techniques to simplify a common fraction, but it's the same principle. Now, if we apply it to a ratio, the main thing is, if we say have more terms in the ratio, 3 or 4 or 5 or 6 or whatever, if you divide one of them by some number, like 100, you have to divide all the terms by that same factor. That's the biggest thing. So if you're simplifying a ratio down, you just have to make sure that you're keeping all the relationships the same. So you divide, in this case we divided both of them by 500 ultimately, 100 and then divide by 5 again. So if we'd had a third term, we would have had to divide that by 500 as well. Or check to see that that would have worked, and if it wouldn't have worked, maybe we couldn't have reduced it quite as much as before. So yes, I'll include that video. It's a little bit longer, but it's got some fun math, I think, in it. And then I'll come back to applying it to ratios for the next video on example 2.